Well, welcome to part 2 of my discussion of time. But first I want to discuss something called the equation of time. Now, to understand the equation of time, you have to understand 0 minutes equals solar noon plus your change in longitude. So for example, solar noon in my time zone will be 12 noon in Albany, New York. I am 9 degrees to the west of Albany, New York, so my solar noon comes 9 degrees later. And at 4 minutes per degree, that means that my solar noon will be 36 minutes later at 12:36. Then I have to take into account something called the equation of time. And this has to do with the orbit of the Earth around the Sun. So now, here around the 1st of February, you'll see I'll have to add nearly 15 minutes to that. And as a result, my solar noon occurs at 12:51 this time of year. Likewise, in October and November, my solar noon would occur 15 minutes earlier than 12:36. Perhaps you're more used to seeing the equation of time in the form of what's called a solar analemma. This is the figure of 8 that is formed by the sun if you take a photograph of the sky at the same time every day for a year. You'll see that the sun changes in declination, and it also speeds up or slows down. By looking at it in graphical form, you can not only tell the declination of the sun at any given month and date, you can also tell the exact correction due to the equation of time. If you compare this to the other graph, you can see that this is simply combined throughout the year as the sun makes its journey from the Tropic of Capricorn to the Tropic of Cancer and back.
Now, as you'll recall, when we calculated the time using the astrolabe earlier, we got a time of 10:25. Yet in reality, the actual time was 11:15. Then we just went through the longitudinal correction and the equation of time to see why that is correct. Well, now that we know how to tell time on the astrolabe, let's see if we can find some times. Okay, so as you recall, I said that this line right here is the horizon line, and it's in the east. This is south, that's east, this is west over here, and north is at the bottom. And we said that today was the 7th day of Aquarius. So what we're going to do is we're going to find Aquarius on the ret, and we're going to put the 7th day right at dawn. And there it is. Then we take our label, and we put our label right over the 7th day of Aquarius, and then we come out to the outside and we read that time. And I'm getting approximately 7:10. Now, we add the 51-minute correction to that, and that comes up to 8:01. Let's see what time dawn is in Gaylord, Michigan. It's 8:04. We're 3 minutes off. That may have been a reading error. How about sunset? Let's go around and have a look at that. Here in the west, here's the horizon line. We line up the 7th day of Aquarius with the horizon line, and then we take our label and read straight out. So according to this, it looks like 4:45. Again, we have to add the 51 minutes. So that would be 5:36 in the afternoon. Let's go see what date and time says. 5:38. Now we're only 2 minutes off. Now the other day I put out a video on twilight, and we talked about the 3 different types of twilight. We talked about civil twilight, nautical twilight, and astronomical twilight. They're marked on the astrolabe as well. Let's have a look. So just as this was the horizon line, this dotted line is 6 degrees below the horizon, and that would be the beginning of civil twilight in the morning. Here we have a line that is 12 degrees below the horizon. That's the beginning of nautical twilight. And then finally, this dotted line down here, that's the beginning of astronomical twilight preceding the dawn. So we're going to find out what time those are going to be. So once again, we're going to go to Aquarius, and it's going to be the 7th day of Aquarius, and we're going to find the time of astronomical twilight. We line it up with the 18-degree dotted line, and we get just before 5 a.m. So it's going to be about 5:50 a.m. So we want to go ahead and we want to find the start time of civil twilight preceding dawn today. So we're going to go to the 7th day of Aquarius, and we're going to line it up with this first dotted line. Then we're going to bring our label over, and we're going to see that that's got 6:30 a.m. We add 51 minutes to that, and we should have 7:21 a.m. What time is it noted on date time? Civil twilight begins at 7:30 a.m. That's not bad. How about nautical twilight? Well, we just kind of do the same thing. Okay, so we've got the 7th day of Aquarius lined up with nautical twilight. They meet right there at 6 a.m., so it should be about 6:50. And according to this, we've got 6:57. Not bad. So under most legal systems, what time do you have to turn your headlights on in the evening? It's at the end of civil twilight. So what time is that going to be? Let's go right over here and find out. So this is the evening horizon line right here, this dark line. So we're going to bring over the 7th day of Aquarius. So according to this, that's 4:45. That'll be at 5:35 in the evening. They've got 5:38. That works for me. And civil twilight, that will end, let's see, this is 5:20 plus 51 minutes would be 6:11. What do they have here? They've got 6:09. So that's how you use an astrolabe to tell time, and that's the solar time. And then we learned how to convert solar time to local time.
Well, now that we have a basic understanding of the equation of time and the differences of time by longitude, I want to show you a rather remarkable instrument, one that I'm thinking about building myself. This is a special type of a sundial called a heliochronometer. And the reason that it's called a heliochronometer is that it is extremely accurate. And I'm going to show you the reason that it's so accurate. Now, a couple of things that you'll notice is that it's set up on a north-south line, and this is basically surveyed in. And then it is also set up according to the latitude where it is installed, in this case 34 degrees north. Now the design is rather simple. There is a rotatable arm right here and a paddle that has a hole to allow some of the sunlight to pass through it and to form a dot on the far end of the movable target. Now, the interesting thing about this target is notice that it is curved to correspond to the radius of this sight line. And notice as well that there is a solar analemma drawn on the target and that it is inverted. In the northern hemisphere, the small loop is generally on top and the large loop is on the bottom. You also have the months denoted along the side of the solar analemma. When you rotate this arm, you can set that dot of the sun up on the corresponding portion of the solar analemma. Notice that he has the sundial marked up in 10-minute increments. That would be 8 o'clock, 8:10, 8:20, 8:30, 8:40, 8:50, 9 o'clock. And when everything is aligned, you simply read off the time. Now, another interesting feature of this heliochronometer is that this dial is movable. So when you switch from standard time to daylight savings time, you can loosen this screw and rotate that entire dial over to make 12 o'clock standard time read 1 o'clock daylight savings time. Now, the interesting thing about this heliochronometer is that it is literally accurate to about 1 minute. Yet this arm is probably 8 or 10 inches long. So despite a rather short radius for the sun, he's getting 1 minute of accuracy out of this, maybe 2. I think that I can do a little bit better. First of all, I'm going to go ahead and build one of these, and I'm going to use a Lazy Susan with a diameter of 32 inches to make the sight line and the radius of the sun. I'll have to scale the solar analemma properly, and it obviously will need to be set up correctly and calibrated to my latitude and longitude. The other thing that I'm going to use on it is a Vernier scale. Now, a Vernier scale will allow me to read the sundial between marked increments. And we'll go over this when I actually start designing it and putting it together, but I've done some tests on it, and I think that I may be able to get as much as 1 minute or 30 seconds accuracy out of mine. But that's going to be a project for this spring. I do appreciate your support of this channel and my other channels as well. I hope you'll consider subscribing to all of them and hitting the bell icons. If you'd like to be a member or a Patreon of the channel, your support would certainly be appreciated. So until our next visit, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by, and stay well.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob the Science Guy. Bob the Science Guy.